Schneider Electric is proud to sponsor this podcast series. With a purpose to empower all to make the most of our energy and resources, our mission is to be your digital partner for sustainability and efficiency. At Schneider, we call this Life is On. Know more at se.com/au. My name is Jo Taranto and I'm joined today by Aravind Surapeneni, Senior Research and Planning Scientist at Southeast Water. And today we're talking about biosolid to biochar technology. Aravind, thank you for joining me.
Thank you, Jo. Good to be here.
How did you get involved in the project that you've been working on with Southeast Water?
Jo, Southeast Water is constantly looking for developing innovative technologies to solve industry problems for the benefit of our customers. So 7 years back, we started off doing a project with the RMIT master students on converting biosolids to biochar. Those two student projects led us to a business case to develop a research project on converting biosolids to biochar using pyrolysis technology patented by RMIT University, Professor Kalpit Shaw.
And so you had quite a lot of partners in this project, like any good project. Tell us about who worked on it with you.
This is a Southeast Water initiated research and development project and co-funded by RMIT University, Intelligent Water Networks in Victoria, and later on we got Greater Western Water as a project collaborator as well.
And this is, would you say, first of its kind of this project in Australia?
It is first of its kind in Australia, Jo, for sure. But what we did was we started off doing a bottom-up approach. We didn't want to buy the technology off the shelf. We want to understand our biosolids because biosolids is a unique biomass. It's a different material to other organic biomasses. So we did some laboratory experiments, some bench scale experiments, semi-pilot plant and pilot plant. So we finished our pilot plant, and this is one of the novel fluidized bed pyrolysis technology.
And is this the new technology, the Pyroco technology? Is that what's being developed?
Pyroco is a trade name for this pyrolysis. The actual technology itself is that pyrolysis is a slow combustion of biomass, any biomass under low oxygen conditions.
And what is biochar then?
Biochar is a organic material. It's like a charcoal, if you like, Jo. It's like a charcoal can be created using any biomass, but combusting by burning, if you like, and burning under high temperatures. By the way, charcoal is like, we all know what charcoal is, and charcoal we can eat charcoal as well. Good old days, people used to brush their teeth with charcoal.
And is it done in an environment where there are specific conditions?
No oxygen or low oxygen conditions and at high temperatures. This particular technology, Jo, unlike any other incineration technologies or gasification technologies, this technology doesn't have any moving parts. It's all about having tubes and pipes.
And why is biochar an important part of the water industry, do you think?
Very good question, Jo. One of the problems the water industry across Australia, not only across Australia, but across Europe and Northern America is facing is the issue of emerging contaminants. Because of water industry doesn't have any control on what's coming into our treatment plants. For example, PFAS, firefighting foaming chemicals. PFAS is a chemical in everyday consumer commodities, like your frying pan and your carpets, for example. So those PFAS chemicals are not safe. So we want to remove PFAS in our biosolids. At the moment, the only technology available is to treat the biosolids at higher temperatures. So in biochar itself, there is no PFAS. Biochar got other benefits as well, Jo, by the way. So biochar is so big, and by converting biosolids to biochar, we are reducing the volume of the biosolids, and it's a safe product.
Are there benefits for industries outside water?
The primary uses for biochar could be in agriculture. So most water authorities, they have their own agricultural land, so we can put them back on our agricultural soils. But also, Jo, biochar got a room in non-agricultural industries like making roads, for example, and rubbers. So biochar got a lot of other benefits which need to be tapped. There's a lot of work to be done, Joe, in this. We haven't really explored those uses in depth.
You're listening to the Australian Water Association podcast series, and I'm speaking with Aravind Surapeneni from Southeast Water. What does the high temperatures for biochar do to give that confidence about product safety? And you've talked about it with PFAS, but what is it about that really makes this biochar very safe?
The high temperatures, Joe, will destroy all the pathogens in the biosolids. So that makes it a safe product. Not only it does destroy pathogens, Joe, but also it will, as you said, it will remove the PFAS and also the other emerging contaminants like microplastics, pharmaceuticals, and any other chemicals.
I've heard a rumor that during some of your presentations, you've even tasted the biochar that you've brought with you because to demonstrate how safe it is. Is that right?
It is 100% true, Joe. Some people didn't believe it and I had to taste it again for them. But my whole point was not to dramatize it. I just want to prove the point that biochar is a safe product.
So what other research is required? You talked about this as an emerging technology, which often means that a lot more work's required around the research and development. What do you think the needs are there?
The biosolids biochar, or the biochar coming from biosolids as a feedstock, is a new material. It's a new product for us we are dealing with. Therefore, we need to do a bit more research and understanding the real benefits of this biochar. For example, if we want to use biochar in agriculture, we want to understand the agronomic benefits of using our biochar in agriculture.
And anything else?
I was just telling before, Joe, we need to focus not only on agriculture uses, but non-agriculture uses of biochar, and there's a lot of work to be done there.
I'm going to put you on the spot. Is there any adverse implications for converting biosolids to biochar? Any outputs that might be concerning or is it expensive?
It's a fair question, Joe. Generally speaking, Joe, the biochar itself is a very safe product. One thing we need to convince ourselves and convince the community is the heavy metals in the biochar are generally locked up in the organic carbon fraction. We need to do some trials to demonstrate that those heavy metals are not leach into the system. Generally, they are bound to the biochar carbon, but we need to prove it to make sure they don't leach.
What do you think is next for this technology and for biochar in general?
So I was telling you before, Joe, there is a great need for Plan B options for biosolids management. The current option, the current business as usual management practice for biosolids is to put biosolids in agriculture because of this emerging contamination issues and the strict guidelines on PFAS. We are constantly looking for Plan B options, and this biochar seems to be the good option. And most water authorities in Australia and across Europe and North America are looking for thermal technologies, and so it's a bright future for biochar in the water industry. And we are looking forward to work with not only with the water utilities in Victoria, but water utilities across Australia.
Aravind, do we have real-world examples of biochar being created and used?
Biochar is the chicken and egg situation. There's a lot of demand for biochar, but there's not enough biochar. Somebody has to start somewhere. So we recently convened a market research on biochar, and those market results are very, very promising. It is opening up lots of new markets. That will take time, but it will happen.
Is there anyone else doing this?
So in Australia, Joe, local council in Queensland did this gasification plant trial, and they are they're currently commissioning their own plant, converting biosolids to biochar using gasification technology. And we are working on a different technology, a different platform, but there's no competition. We are all working for the same cause. So there's a room for all technologies.
I've been speaking with Aravind Surapeneni, a senior research and planning scientist at Southeast Water. Thanks for your time, Aravind.
Thank you, Joe. Thank you very much.